Hello, welcome back to the COVID-19 inspired video series for Mr. Billingham's Honors Pre-Calculus class. Today we're going to be looking at Part C of the Introduction to Probability section 10.1. We'll be using Venn diagrams to find probabilities. The first problem we're going to look at involves Pascal High School, where it's known that 54% of the students are girls and 62% of the students play sports. Also that half of the girls at the school play sports. We have two questions to answer, but first let's set up a Venn diagram to illustrate the data that we have so far. We'll draw one set for the girls, 54%. We add a second oval to illustrate the sports, being 62% of the students in the school play sports. And that is our Venn diagram. So we have girls overlapping with sports because clearly there are going to be some girls that play sports. Everyone outside of the girls is a non-girl, also known as a boy. Everyone outside of the sports oval is someone who doesn't participate in sports. And so the intersection of the two circles would be girls who do play sports, and the area inside the rectangle but outside the two ovals would be boys who do not play sports. Let's see if we can put some numbers in there. We know that 54% of the students are girls, and we know that half of the girls at the school play sports. Putting that information together, 27% of the girls must not play sports, and 27% of the girls play sports. Sorry, 27% of the students are girls who play sports, and 27% of the students are girls who do not play sports. So 62% of all students in the school play sports, and we know that 27% of the students are girls who play sports. What does that leave for the boys who play sports? Since 62% minus 27% is 35%, we know that 35% of the students are boys who play sports. Let's annotate these all properly. In this region, we have girls who aren't in the sports oval, so these are girls who don't play sports. This region is the overlap of girls and people who play sports, so 27% of the students are girls who play sports. Finally, this is sport playing but outside of girls, so this region would be boys who do play sports. What is this region out here? Clearly, if you're in the region inside the rectangle and outside of the two ovals, you can't be a girl and you don't play sports, so this region would be boys who don't play sports. We can see now that the entire region is made up of four separate zones. The yellow zone, girls who don't play sports and are 27% of the student body. The girls who do play sports, 27% also of the student body. Boys who play sports, 35% of the student body. So what's left in the red zone would be non-sport playing non-girls, in other words, boys who don't play sports. And since 27 plus 27 is 54 and 35 adds up to 89%, that means that the boys who don't play sports must be 11% of the student body. Now that we've done all of this work, let's look at the two questions they're asking. First of all, what percentage of the students who play sports are boys? Notice we're limiting ourselves to the students who play sports, which was 62% of the student body. But we found out that 35% of the student body are boys who play sports. So what percentage of the students who play sports are boys? That would be 35% over 62%, which is about 56.45%. Now for B, If we choose a student at random, so that could be anyone at all in the red, green, yellow, or blue zone, what's the probability that it's a boy who does not play sports? Well, this one is a little easier. We already calculated it was 11%. So here's a new question. What's the probability that a student at Pascal High School is a girl or plays sports? Since we knew that 54% of the students are girls and 62% play sports, you might be tempted to add them. The problem with that is you get 116%. If you think about the question while looking at the nice Venn diagram we have, when adding 54% percentage of students who are girls and 62% the percentage who play sports, you'll notice that we added the green and the yellow zone, and then the green and the blue zone. So we've added the overlap twice. In mathematics, the word or is said to be inclusive. The statement A or B is true when A is true, or when B is true, or even when both A and B are true. In this case, the 27% green zone got added twice. It's the intersection. And so the way we need to do this is we add up the 54% girls plus 62% sports, and then subtract the 27%. So 89% of the student body are either girls or, in a mathematical sense, play sports. I hope that was clear. And this leads us to the following pretty important rule in math, or at least in probability. So the probability that A or B is true is the probability of A plus the probability of B minus the probability of A and B. Or in set notation, probability of A union B is probability of A and probability of B minus probability of A intersect B. Now notice that if there is no intersection, then A intersect B is the empty set, and you'll find that the probability of A or B is just the sum of the probability of A and the probability of B. Think, for instance, of rolling a pair of dice and getting a sum of either 11 or 12. There is no overlap of getting an 11 and getting a 12. You can't have both happen, so the intersection is non-existent. So to calculate the probability of getting an 11 or a 12, you just add the probability of getting an 11, which happens 2 out of 36 times, and the probability of getting a 12, which happens 1 out of 36 times. So the probability of an 11 or 12 is 3 out of 36, or 1 out of 12. This important principle is called the addition principle of probability. Basically, it's the problem of the probability of a union is the sum of the probabilities of the two events minus the probability of their intersection. Let's take a look at another important idea, applying this to another Venn diagram at Pascal High School. So back at Pascal High School, we find now that 68% of the students have cell phones, 77% have iPods, and 62% have both a cell phone and an iPod. Let's answer these two questions. What's the probability a student has a cell phone or, in the mathematical sense, an iPod, or a cell phone or an iPod, but not both, which is an exclusive or? First, we draw an oval to represent the 68% of students that have cell phones. I add another oval to represent the 77% of students that have iPods. Since we know that 62% have both a cell phone and an iPod, we can get more data. My finished Venn diagram should look like this. 6% of the students have a cell phone but not an iPod. 15% have an iPod but not a cell phone, and 62% have a cell phone and an iPod. So let's answer the question. What's the probability they have a cell phone or an iPod? Well, I could either do this by doing 0.06 plus 0.62 plus 0.15, which is 0.68, and 0.15, which is 0.83, or 83% of the students. Or I could have done it using my probability of an or statement, which would be the probability that they have a cell phone plus the probability that they have an iPod minus the probability of their intersection. And this would be 0.77 plus zero point 0.6, or 0.83. Now the last question, what's the B? What's the probability they have a cell phone or an iPod, but not both? Well, that would be 0.06 plus 0.15, or 0.21, or 21%. Okay, that's the end of the mini lesson on Venn diagrams and probability.